Coulomb's law. French scientist Charles Coulomb, he measured electric attraction and repulsion between two electric charges. He did many experiments, and he also deduced a law that governs these the outcome of his experiments, and which is known as Coulomb's law. So what is the Coulomb law? He said that the force, or the electric force, also known as Coulombian force, between two stationary point charges is directly proportional to the product of their charges. If this is Q1, this is Q2, then this force is directly proportional to the product of their charges. And if the distance is r, then it is inversely, this force is inversely proportional to the square of r, to the square of the distance between them. And the force is along the line joining these two charges. So this is the Coulomb law. If you show it mathematically, if the charges are Q1 and Q2 and the distance between them is r, so F is directly proportional to Q1 Q2 by r square, directly proportional to Q1 into Q2, inversely proportional to r square. So if you remove this proportionality sign, we keep some constant, and this K constant is Coulomb's constant, and the experimental value of K was found in vacuum to be this number, but practically we take this number as 9. So it will be 9 into 10 to the power 9 Newton meter square per Coulomb square. In CGS unit, this K is 1. So this is the value which we are going to use. And for more simplification of this formula, in electrostatic, say K, if you want to represent this in the electrostatic term, this K can be represented as 1 by 4 pi epsilon 0. And here we have 4 and pi, and there is one thing called epsilon 0. And this is nothing but epsilon 0 is the permittivity of free space. So K is 1 by 4 pi epsilon 0. This epsilon 0 is the permittivity of free space. So now the equation becomes what? If you take epsilon here, K this side, and put K value as we just discussed, it will be some value, epsilon, 9 into 10 to the power minus 12, to make it approx. The force will be given by K. K can be written as 1 by 4 pi epsilon 0, Q1 Q2 by r square. And these are in vacuum. Now this epsilon 0 is for vacuum, and if you are taking some medium, not vacuum, but if you are taking some medium, not vacuum, then you can put this epsilon 0 as epsilon of that medium. So now the force for that particular medium, this force was for vacuum. Let me write it as Fv. So this is now force for some medium. So it is 1 by 4 pi epsilon. Now it will be epsilon, not epsilon 0. This is for medium, and Q1 Q2 by r square. Now let us take this one, 1.3.2 and 1.3.3. Let us divide them. So Fv by Fm, all other things get cancelled. Only epsilon by epsilon 0 will remain. And this is a special term, or this is a special ratio. We call it as epsilon r, which is equivalent to K. So now what is the relationship? This Fm, or you can say that if you want to find out the force, electrostatic force in any medium, you just have to divide this F by K. So what is this K? This F is the force, electrostatic force in vacuum between these two charges, and K is what? Epsilon r is the relative permittivity. What was epsilon r? Just see, epsilon r was epsilon by epsilon 0. It was epsilon by epsilon 0, which we wrote as K. So epsilon r is called the relative permittivity, or you can call it as K, which is the dielectric constant. K is the dielectric constant. So we'll talk about this in the later discussions, but now it is clear that the force between some charges, two charges here, which are at some distance apart, say in some insulating medium, is only 1 by kth part, 1 by k, that is F by Fm was k. So Fm in any medium is just this force in the vacuum divided by the k, which is dielectric constant, or this Fm is the kth part of F in the vacuum. So we have to remember that Coulomb law holds only for stationary point objects. This law also is applicable for charge objects whose sizes are much smaller than the distance between them. And Coulomb law, if you see, this resembles inverse square law of gravitation. The charge q plays the same role as the mass play in gravitational force. Let me write it again. F equal to g m1 m2 by r square. This is force, gravitational force. And what is the electrostatic force? Let me write it as g. Electrostatic force is k q1 q2 by r square. So they are almost identical, but the gravitational forces are always attractive. But electrostatic forces can be attractive as well as they can be repulsive, because the electric forces, the electric charges are of two types, positive and negative. The repulsive force between two particles of same mass and charge separated by a certain distance is equal to the weight of one of them. Find the distance between them. Mass of the particle is given, charge is given, k is given, g is given. So what the question is saying, the repulsive force between two particles, which is k q1 q2 by r square, is equal to weight of one of the particles. So let us take it as m into g. Weight is m into g. So what do you get? Take r on one side, others on other side, and since they have same mass and same charge, you just have to put this k, which is given, q1 q2 is given, m is given, g is given. G we are taking as 10 meter per second square, and r can be found out by taking the square root of this number. So r is 0.12 meter. Two spheres of copper having mass 1 gram each are kept 1 meter apart. The number of electrons in them is 1% less than the number of protons. So if proton is p, then electron will be 1% less. So you have to take 1% and just subtract it from the original. I'll show you how. Find the electrical forces between them. The atomic weight of copper is this one. Atomic number is this. Avogadro number is also given per mole, and k is also given. So if you have a neutral atom, in neutral atom, the number of proton will be equal to number of electrons, sorry. This will be okay, they are equal. And what are the number of protons? These are 29. So number of electrons are also 29. So these are 29, these are also 29. Now it is given in the question that the number of electrons are less than how much? 1%. So the net charge on each atom is what? First we'll find net charge. That is the total charge on proton and total charge on electron. So total charge on proton is 29e. The total charge on electron is minus 29e, which we are just trying to exemplify and say here that it is 0. Why? Because it's number of proton and electron equal. But what is the difference? The difference is the 29 is the number of proton, and we are taking 1 by 100 of this, 1%. So this will be 0.29. So we have to subtract this with 0.29 electron, and this gives you can take E. I'm not taking E as electron. It is a charge, because we have already taken plus and minus sign. So this is negative. That is the number of electron, which is 1 by 100 of this charge. So this is because minus of minus, this will become plus. So this is 0.29e. This is just 1% of this, as given in the question. So the net positive charge on 1 gram of copper will be what? We have to find the number of atoms in 1 gram of copper. This will be found by the Avogadro number divided by the atomic weight. We know this number of atoms how to find in 1 gram of copper. We know this how to find, and multiplied by this many charges there. So this is the total charge. Now we'll apply the electric force formula. F equal to K, Q, Q, both charges are same by R square, that is K Q square by R square, Q. Now this Q has to be taken this whole number, complete. So take it here, square them, and this is again R is 1, the distance is given as 1 meter. And 1 gram is there, so we found out for 1 gram, and this is the number if you simplify it. So in this example, you see even the difference of 1% between the positive and negative charge on any substance will give rise to a very, very large force. And most of the matters in general, they are electrically neutral. So there is always a dominance of weak gravitational force on them. Charge Q is uniformly distributed over a body. How should the body be divided into two parts so that the force acting between the two parts of the body is maximum for a given separation between them? So we have a body, say this is a body. We divide it into two. Say one is this and one is this. Two parts we have divided. Now suppose the body is broken into two parts. The case is, because the whole charge is capital Q, if we say this has Q charge, this will have Q minus Q charge, right? So the force, what will be the force? Force will be Q1, Q2 by R square. So Q into Q minus Q by R square in K. But if we want this force to be maximum, this whole value has to be equal to 0. So Q into Q minus Q equal to 0, we need to do it. This has to be maximum, right? This quantity has to be maximum. So how to find that this quantity is maximum? If I say Y is equal to Q and capital Q minus small q, this quantity has to be, if F has to be maximum, this has to be maximum. How to find for what value this will be maximum? We have to put this as 0? No. The derivative of this value should be 0, because derivative will show that it has to be 0 so that it becomes maximum. So we'll take the derivative of dy by dq, means dy by dq. This will be q into q minus q square. We have to take derivative with respect to dq, d by dq, and you get q minus 2q, which is equal to 0, and this gives you q equal to capital Q by 2. This is the answer. So we have to divide them. The charge should be half and half between the two parts.